Okay, so it's time for us to do a number 11, I believe. Here we go. Okay, so now we are dealing with something called, we're still dealing with sets. So it's basically the title in your book, which is in 2.2. They call it subsets and set operations. It's more about set operations than anything else. But anyway, that's their title. Let's go with it. Okay, so here's the case. Problem number one. And we're building on the stuff that we had in the previous video. What if you've got a set A, which has got 1, 2, 3, 4, 5 in it? That's pretty straightforward. Okay, and then comes set B. Let me save some space by going this way. Then you got, which has got 6, 1, 3, 7. Hold on. 6, 1, 3, 7. There's more. And then 8 and 9. Okay, fine. Then, besides that, there is set C. We haven't talked about a universal set. We don't need it right now. Whenever you need prime or complement, that's when you need a universal set. But right now, we don't need the universal set. We can talk about that later as we come to it. So now C is got 4, 1, 7, 8, 10, and 11. Okay, that's the deal. Fine. So 2 questions on this so far. There'll be more. But here comes this question, let's call it A, 1A. And A intersect B. All right, A intersect B, look at A and B, look what do they have in common. They've got 1 in common, right? Don't forget that stands for intersect or and. 1's in common, 2 is not, but 3 is. 4 is not, and 5 is not. So basically all we got is 1 and 3. That's it for A intersect B. Okay, fine. Now, here's 1B. Let's go to 1B. How about A intersect B intersect C? That means you got to be in all 3. You have to be in all 3 to make it to the finals here. So 1, is that in all 3? 1 is here, 1 is here, 1 is here. Yes, it is. Let's take the smallest one and check them. Is 2, it's not even in B, forget it. We can know from over here that the only other candidate, because it's in A and B, would be 3. So is 3 is in A and B, but is it here in C? No. So that's it. This is the only one, the only element is the number 1 that's in all 3. Okay, that's pretty straightforward. Problem number 1. Now they could replace this with all sorts of different words in it. They could give you different types of cars. 1, 2, 3, 4, 5 would be 5 different types of cars, right? Whatever it is. I can't think of too many cars. A Chevrolet, this and that, Plymouth, whatever it is. The Nissan. So they could have that and then have different cars here, and then you'd have to look for the common denominator in terms of the cars, right? But I'm using numbers to be as clear as possible. It makes it easier for us to just deal with numbers to make our point. Okay, now what about the next question? A union B. This is 2A. A union B. And what we want is, okay, so let's do A union B. We talked about this already. So 1, 2, 3, 4, 5 qualifies. That's in A, because we'll take you if you're A and in your B, and if you're in B, we'll take both of you, or if you're in B. Either one is good. So from B, we'll take the 6. We don't take the 1 again. Don't repeat. No, the 1. We don't take the 1 again. We don't take the 3 again. But we'll take the 7. We'll take the 8, and we'll take the 9, and that's it. All right. What about 2B? Here's my next question. How about A union B union C? That means we'll take you no matter which set you're in. We'll take you in all 3 sets. So of course 1, 2, 3, 4, 5 makes it in. 1, 2, 3, 4, 5 makes it in. So does 6, 7, 8, 6, 7, 8, and 9. They're in B, so they make it in. 6, 7, 8, and 9. Now we have to deal with C. 4's already there. Don't repeat it. 1's already there. Don't repeat it. 7's already there. No repeat. 8, no repeat. 10 hasn't gotten there yet, so 10 gets in. 11 gets in, right, from C. And we're done. That's it. That's how you take care of these relatively straightforward problems. Now, it can get a little bit more complicated, admittedly, so just bear with me a little bit. All right, so let's try problem number 3. Where you can see A and B up there. I know it's a little obscured, but you can still see A and B up there. A on the left, over here on the left, 1, 2, 3, 4, 5, and you can see B. Now, for problem 3, I want to bring in the universal set. The universal set is 1, 2, 3, 4, 5. Obviously, it's got to be all the ones that we've already seen. It's part of our universe. But there was more to the universe that we didn't see yet, and that was simply 12, 13, and 14, and that's the end of the universe as far as this problem is concerned. That's the universal set. Here comes the next question. 3A. Put it over here. A prime intersect C prime. Now it gets a little bit more complicated. Now we got to deal a little bit with scrap paper. All right, so on my scrap paper, it's not the final answer. On my scrap paper right over here, let's figure out what's A prime. Okay, A prime is everything in the universal set, but not A, right? So what's A? We have it up here. You can still see it. I know it's a little obscure. You can still see it up there. 1, 2, 3, 4, 5. So everything in the universal set is 6, 8, 7. That's not and that's not an A. That's A prime. 6, 7, 8, 9, 10, 11, 12, 13, and 14. How about C prime? So we got A prime. This says A prime intersects C prime. So we first found A prime. Now let's go for C prime. C prime, as we've just explained, will be everything that's in the universal set, but not C. Okay, so C has a 1, so C doesn't get into C prime. 2 gets in because C doesn't have it. 3 gets in because C doesn't have it. Look up there. Just look up here while I'm doing it. You can, and I don't take 4, but I do take 5. I do take 6. I don't take 7. Don't take 8, but I do take 9. I don't take 10. I don't take 11. I do take 12, 13, and 14. Now we have 2 new sets, A prime and C prime. What's the last? And this will be the answer. Right over here will be the answer. The last set, A prime intersect C prime. We'll have the answer hopefully in a minute. What are common to both A prime? It's got to be in A prime and in C prime. Where do they intersect? Well, do they both have 6? Yes, they do. 6 and 6. Do they both have 7? No. Do they both have 8? No. Do they both have 9? Yes. Do they both have 10? No. Do they both have 11? No. Do they both have 12? Yes. Do they both have 13? Yes. And do they both have 14? Yes. There it is. There is the final answer right over here. Is the final answer. A prime intersect C prime. Okay, so that is a good deal of explaining about how these set operations work. It's building on the stuff that we said before. It's really not that much new, but we got to get used to a little bit more complicated situations. We've got some more time on this video. Let's keep going with a fresh piece of paper. Okay. So now we can run up against something like the following. The same, I'm going to have to rewrite A again, I guess, because you need it on the top of your paper. We're going to have to do it again. I'm going to do a similar problem that I just did before, but it eats up some paper. So here's A again. Here is B again. Got to give you B again. Okay, bear with me. It's 613. 613, and then it was 7, 8, and 9. Okay, hope I'm writing that down correctly. I'm pretty sure I am. And then there was C, which was C was 417. 417, and then 8, 10, 11. 8, 10, 11. That was it for C. The universal set was 1 through 14 inclusive. Okay? I wrote it down the whole way the other way, but now we can just do it with a little bit of saving of time. Okay, now let me ask you a little bit more complicated question. What if we ask you like this? This will be called, I guess, problem number 3. It's either 3 or 4, but it's okay. It doesn't matter that much. That I can afford to make a little bit of a mistake. Anyway, A intersect B, in parentheses, prime. That means prime the whole thing. First figure this out, then prime it. I can explain a little bit more in a second. Just bear with me. Then after we finish figuring that out, then C. Okay, so we've got, here's scrap paper work. Scrap paper work. Here's what we got to first figure out. What is A intersect B? We did it on the previous page. But let's just do it again quickly. What's A intersect B? I seem to remember it's 1 and 3. Is that correct? 1 is in both, 3 is in both, and that's it. So A intersect B is 1 and 3. Okay, now that's fine. That's very good, but we need much more. We need to know what is A intersect B prime, meaning everything that's in the universal set, but not A intersect B. Well, that's not so hard because it's everything except for 1 and 3. So it's 2. Sorry about that. It's not 3. It's 2, 4, then it's 5, 6, 7, 8, 9, 10, 11, 12. And usually I do not go to a second line before I close up a set, but here I'm doing it. And there is the end of the set. There is A intersect B prime. It's everything in the universal set except for A intersect B. That's what prime does. Everything but. And we need the universal set. Everything in the universal set, but what's in A intersect B. If the prime is next to the A, it's everything but A. If it's next to the B, it's everything but B. But if it's A intersect B with parentheses, then it's everything except for this. Okay, fine. Here we are. Now, we've got to intersect that with C, meaning we need this set to have something in common with C. Intersect's got to be in this set, this new set we created, and in C. What is in here that's also in C? Is 4 inside this thing? So here comes the answer right now. We're setting up the answer right now. Is 1 in C? Yes. Is it in our new contrivance over here? A intersect B prime? No, 1's not in there. How about 2? Is 2 in both? No. Is 3 in both? No. Is 4 in both? Yes. I'll show you. Right here and right here. 4 is in both. Okay. How about, I'm going to go down the line of C. C is the smaller one, so I might as well go through C. Is 7 in both? Yes. 7 is in C and is in our new one. Is 8 in both? Yes. Is 10 in both? Yes. Is 11 in both? Yes. There is the final answer for A intersect B prime and C. Here is the answer. These type of problems take a little bit longer. Okay, that is the story with that. Here we go with at least one more problem. At least one more problem before we finish this thing off, which is, we did A and B, right? Okay, here comes set subtraction.